So today, lesson 9, we're continuing the second part, which is 5 to 6. There's not much to do here. We're gonna get assessed on 5, and then on 6 we have some levels of challenges, same as in 4. So it shouldn't take you more than, I would say, like 30 minutes. All right, if you really want to do it. Actually, it takes you shorter than 30 minutes. So we did 4 last time. If you were absent, you can check the video. It's been uploaded. Now we're gonna go on 5 and check what kind of assessment we have. All right, so 5, make it fit. So let's run this. Okay, so as you can see, the foot is actually, it's been, yeah, it looks like, all right, let me reset this because I don't remember doing this one. So you are able to reset everything, particularly that task, not the whole level. So you see, now you see that's how it's supposed to be originally. So what we're gonna do here is, I just remind you, we've been working with properties of sprites. When we say a property, we think of a color, we think of a size, we think of a location along x-axis or y-axis, particularly those 4. Okay, now in this case, as you can see, it's way too big for the plate, so we want to change the size. And then if you guys remember, the property which responsible for size was a property called scale. So we want to locate the scale of each variable, each sprite. As you can see, there's no scale here, so it's been declared, it's been assigned a so it's been declared, it's been assigned animation, and it's been drawn, but there's nothing about the size. So we want to add a size, we want to add a scale for every single sprite. So these 2 responsible for one sprite, these 2 for other sprite, and then the last one for the third sprite. Now I'm gonna start with fries. So I'm gonna add sprite, make sure the name matches fries, and also scale it. So this is the original scale of fries. So if you guys put 1, there will be no difference. We want to make it smaller than 1. So how much smaller? I would say like a half. If you want to make it a half, it has to be 0.5. So we reset, run, and check it. Yes, that's small enough. And again, it's up to you. You can make it slightly bigger by playing with this number. Again, I need another scale for a sprite number 2, which is burger. Make sure the name match. We type burger, burger, and also do that again, 0.5, half the size. Reset, run, yes, and then also change the last sprite, so it's also missing scale. We add a scale here too. We make sure the names match. We name it dessert, and also add 0.5 scale, which makes the original size half the size. Reset, run, and as you can see, it fits. If not identical, like exactly like here, but still good enough because it's in the plate. All right, click on finish. Actually, let me pause it. Finish. Proceed to next task after tutu sound, which means we did it. So there's only 3. Okay, new block, tint, alpha, and then height and width. So height and width was we didn't have this property, but I guess it's not gonna be a big deal because you know what scale is, you know what rotate is. So adding extra properties shouldn't be a surprise. Okay, now let's start with A. As I said, we do all of them because we split it into 2 days. Now, this is a property that will overlay color on top of the sprite to tint in. So this tint doesn't change the existing color of the sprite, but it's more like putting a pane of colored glass over the top of the sprite. So it's kind of make it a little pale, maybe transparent. Let's see. Okay, so what we're gonna do here, using either sprite already created for you or with any other sprites of your choosing, play around with the tint property. So let's locate the tint property. Let's check on the sprites and tint here. So let's add it. Okay, and then we make the names match, creature, and also add some numbers. I don't know. Let's start with 1. Let's see how much change it. So this is the original look. I added tint. We reset, and you see it's overlaid with another layer of color. So let's make it maybe 0.1, which is 110%. Okay, what's the range? Let me see. I think we need to indicate with a color name. Let's put yellow. Nope, doesn't work. Okay. Let's make 100. Oh, put quotes. Good. I forgot. Yes. For certain names, we need to use quotes. Yellow. It's a high from the space. There we go. Yeah. Thank you. So, yellow. Do you think we can use RGB? Shall we try RGB? Do you remember how RGB works? It's like 3 numbers separated with comma. Let's try that. I don't know if it works here. So R for red. So I'm going to go with 255. Oops. 255. 0 and 0. Let's see if it works like this. Seems like, oh, no, it doesn't. It doesn't. Let me try again. No, it doesn't. Okay, so yes, I guess we're going to use quotation quotes and then just some colors. For example, let's try purple. Purple. Reset. Yeah, it works. So just use colors with within quotations, quotes. Okay, that was task A. Finish. And so let's check the B. Height and width. So we're gonna stretch the sprites, stretch them out. Wider, higher. So height and width. So using either sprite or adding another one, play around with the height and width properties and think about when you would want to use these properties versus using the scale property. So guys, what do you think is the difference between width, using width height versus a scale? What do you think is the difference? Any suggestions? Say it again. The fee? Yeah. No. No, the question is, what's the difference of using scale versus height and width? That's the question. I guess scale is not going to change the ratio of width to the height. You know what ratio is, right? Ratio. So, for example, if I have a rectangle, 3 to 8, 3, height is 3, width is 8. If you don't change the ratio but make it bigger, so what would be another equivalent rectangle to it, but with the same ratio? For example, 3 to 8. You multiply each with 2. It's going to be 6 to 16. Same rectangle, bigger, but the ratio is the same. So scale does not change the ratio, if that makes sense. Again, scale doesn't change the ratio. But width and height, it actually change the ratio, okay? It can make it much wider than the height, or can make less higher than the width. But on the scale, they follow the proportion and just expand at the same time. That's the difference. So let's use width and height here. For example, this is kind of fat, right? Let's give it a little better shape. So we want to make it less wide. So add a wide, put it sprite. The name matches. And then let's see 0.5. Oh, way too small. Okay. Let's use 200 pixels. I think it's based off pixels. There we go. Okay, now I know it's if this is 200. You see this 200, like from here to here is 200, the pixel. Then what would be the perfect size? I would say 100. Let's try 100. Yeah. Maybe a little thinner. Let's make it 75. No, 75. I said 750. There, right? And a little taller. So you see, using height and width is allows me to regulate or change height and width separately. But if you were to use scale, you have no power over width and height. They both are changing. They are related to each other. They are kind of proportional to each other. So there's nothing you can do in the scale. But in the width and height, you totally can assign any width and any height. So that's the difference. For height, let's do it maybe 350. There we go. Maybe 400. There we go. Yeah. Okay, maybe a little thinner, 50. Yeah, there we go. So that's width and height versus scale. And the last challenge of task 6 is called alpha. Alpha is actually adding transparency. It's not adding a layer of color. It's just literally making your object transparent. All right. So what is the transparency if you don't see the object? What's the level of transparency, guys, in percentages? What do you think? If something is like super transparent, 100% transparent it is, percentage-wise. 100. 100 means you literally don't see anything, right? Don't see. But it's less than 100, it's going to be a little cloudy. And the bigger transparency level, the most likely you're not going to see it. The lower the transparency, the more likely you're going to see it. So we're going to add a transparency here. So you see this ghost? Ghosts are known to be transparent, right? That's why we call them a ghost. They're like not like physical thing. It's like actually physical, but yeah, you know what I mean. Ghosts are seen as a transparent because they can go through the wall, supposedly. Now let's add a transparency by using alpha. So ghost, let's make sure the names match. Okay. And then, so if you guys do it 100, 1, it's going to be invisible. It should be. Oh, no, it's not. 0. Okay, let's try 0. So 0 makes it invisible. Yeah, you see, invisible. So in this case, it's the opposite. They did it the opposite. But normally in Photoshop, you would based off percentage 100. 100 would be super transparent. Less would be not transparent. Okay, let's do it 0.5. So halfway transparent. And then this is how it's going to look like. So it's, huh? Yeah, I'll just leave it like that. So this is it. This is pretty much it. All we have to do was just complete it, guys. Thank you.